Okay, this is section 6.4 on inverse functions. An inverse relation switches x and y. That's the whole idea here, guys, is we're going to have a relation. Remember, a relation is a group of numbers. Sometimes it makes a function, sometimes it doesn't. Okay, so here's our relation. It's an xy table. If I want to find the inverse of this relation, all I'm going to do is I'm going to switch x and y. So 0, 6 becomes 6, 0, and vice versa. Okay? Here's the graph of the relation. You can see all of the dots of this relation in blue. Okay? Then, if I were to graph the inverse, that's in red here. What you can see is that they're actually a reflection of one another. It's flipped over the line y equals x. Okay? So, an inverse and an original relation, or a function or a line, they're reflections of one another. To figure that out, when you have a line, what we're going to do is switch x and y. So here we have y equals 3x minus 5. First step is we're going to write the original one. To find the inverse, I'm going to switch x and y. Now I'm going to solve for y. I don't want my function in x equals form. I can't graph that way. We add 5 to both sides. Now we're going to divide by 3. So I get x plus 5 divided by 3 equals, now we're going to call it something a little different because y is 3x minus 5. So this one has to be called y to the negative 1. I'm not going to think of that as an exponent. I'm not going to say, oh, got to put it over 1. No, don't have to do that. That just means y inverse. That's all I'm saying. So y inverse is x plus 5 divided by 3. Don't forget, guys, if you had to graph this is still in slope-intercept form. All we would do is just split it up a little bit. We would say x over 3 plus 5 over 3 is y inverse. Then if you wanted to go a little further and find that slope, remember there's a 1 hiding in front of x there. So that is also 1/3 x plus 5/3. Okay? So the whole idea, switch x and y, solve for y. Okay, now here's a little reminder of what we talked about last slide. How if you have f to the negative 1 of x, it's not saying 1 over whatever your function is. Okay, that's just saying it's an inverse. Let's say I had two functions and I wanted to check if they're inverses of one another. What I'm going to do is I'm going to find the composition of each function. I'm going to take the inverse and put it into the original, simplify, and see if I get x. If I do, I'm in business. That's good. Because according to this definition, when we put each function inside of each other, you should get x for both of them. If you do, it means they're inverses. If you don't, not inverses. So for this one, we are going to start by taking our inverse and putting it inside of our original function and see if we can get x. So we're going to start with the regular function as the outer function. The inner function is going to be that inverse. I like to be very detailed with my work for these composition functions. Okay, so what I'm going to say is, I know what f inverse is. F inverse is this function here. So I'm going to put that in my parentheses. That helps me see that, oh, all I have to do is go back to my original function, and everywhere there's an x, I want to put this function. Okay? I'm just being tricky here, guys. So I'm going to go back to my original because this says f of x, or f of this function, not f inverse. F inverse means this one. So f is here, so I'm going to go 3 times 1/3 x plus 5/3. Okay, that's my x, minus 5. Now I'm going to simplify, see what I get. I have a number on the outside. We're going to distribute to the front. 3 times 1/3 is just 3/3. 3 times 5/3 is 15/3. We multiply straight across the top. And then you have a minus 5 at the end. 3/3 is just 1, so that's just x. 15/3, 15 divided by 3 is 5. Oh, look at that, 5 minus 5. Bam, we're left with x. Okay, so that one's good. Now we got to do it the other way. So the other way is I would take the original function and put it inside the composition. Not the composition, the inverse. I would take the original function, put it in the inverse. Together it makes that composition. I'm going to have you guys go ahead and give it a try. I will put my work up there. See if you can simplify it to get x. Okay, so we did our one way, now we're doing the other way. We are taking the original function or putting it into our inverse. When we do that, we are replacing x in my inverse function, or my outer function. We're replacing x with that other function, okay? I'm doing that right here. Then we need to simplify. We're going to take that 1/3, distribute it, simplify, remembering our fraction rules, or how to use our calculator, and we simplify it and we get x. So that tells us since we did the composition one way, we did it the other way, we both got x, we're good to go. They are definitely inverses of one another. Okay? So for your answer for this one, you would want to show each composition, because that's like your proof that they are inverses. Then you also want your conclusion on there as part of your answer. Now, I'm going to get into graphing a little bit. Okay? The whole idea is when you have an original function, for example, we have x squared here. You guys know that makes a parabola. If we were to find the inverse of that, switching x and y and then solving for y, we would end up with something like this in the red. That is not a function, and there's a few ways we can test that. I wonder if you guys remember way back when we started this, you guys learned about a vertical line test. If you draw a vertical line through the graph of a function, it should only cross that graph in one spot for it to be a function. You guys can see our vertical line crosses that function in two places, so it's not a function. Here we have our regular x to the third function in blue, and then the inverse of it in red. If we were to draw a vertical line through the red, we're good. It's a function. So when this happens, when it's not a function, what you will sometimes see is they'll have a restricted domain. So they will tell you x's are only allowed to be positive or negative. They'll restrict it to make it a function. So what we want to do is we're going to find the inverse of this function. You can see that restricted domain there because we have that parent function. Then we're going to graph it.